Welcome to qnawire.
Okay, we've got two cyclohexanes. We've got one 4-dimethyl cyclohexane, trans, and we've got cis 1-terbutyl 3-methyl cyclohexane. And the question is, which of these will have a higher percentage of the diequatorial-substituted conformer compared to the diaxial-substituted conformer? So to answer that, I think it would be worthwhile to draw the chair conformations of these molecules. In particular, I think it would be good to draw whichever is the lowest or the highest energy conformer. So in terms of this dimethyl, we're going to put axial methyl here and axial methyl here. Okay. Oh, that's 1,3, not 1,4. Okay. 1, 2, 3, 4. Yeah. Okay, so it's the lower. Scroll down a little bit. Okay, that's the diaxial. And then for the 1,3 cis 1-terbutyl, do the same. And we'll go axial T-butyl here. And 3 carbons away, if it's cis, the group will also be axial. Okay, so these are the two, this is the comparison, right? This is comparing the diaxial of the dimethyl to the diaxial of the methyl T-butyl, terbutyl. Now recall, it's not necessary to draw it out, but I suppose I can, that the ring flip conformer of either of these is simply the diequatorial. So the question is, which of these will spend a greater portion of its time in the diequatorial? Which is another way of asking which has a more or a less favorable diaxial conformer, right? Which of these is less favorable or to a more less favorable than its equatorial counterpart? So that's really comparing methyl to T-butyl, right? We can kind of say like this is the same as this, and that the real only difference here is this methyl versus this T-butyl. Or we could say, this interaction is different than, say, this and this interaction, right? We've got a methyl interacting with 3 hydrogens down here, and we've got this methyl interacting with 3 hydrogens up here. So we're saying, is it better to have a methyl interacting with a T-butyl and a hydrogen, or a methyl interacting with 3 hydrogens and another methyl interacting with 3 hydrogens? And it's this one. This is the far less favorable conformer when you compare it to its equatorial counterpart. Recall that methyl, even just methyl 1,3 interactions are highly unfavorable. Methyl T-butyl 1,3 interactions are even more disfavorable, right? This T-butyl group, if we actually draw it on here, is pretty massive, right? It's going to be, and then each of these is going to have 3 hydrogens. In fact, you are going to get what's known as I believe, a syn-pentane interaction, which is one of the least favorable. Let's see, 1, 2, 3. 5. Yeah, that's syn-pentane interactions. These hydrogens are literally nearly touching, right? And that just doesn't happen over here. So the difference in energy between the equatorial and the axial when it comes to the methyl T-butyl is far greater than the difference in energy when it comes to the dimethyl.